Hello, and welcome to Quantitative Reasoning Online, Lesson 13A Preview. Okay, so today we will be doing 13A Preview assignment, which is going to be a tutorial and 5 questions. So let's see what we got here. Mind the gap in income inequality. Good social issue. And what's the purpose of today's tutorial? One is describe a way to use sample data to describe a population. Okay, so we're doing data. Determine the variables in a statistical study. Explanatory responses. Identify variables as quantitative or categorical. Big picture here. Quantitative. Can you count it? Can you count, measure? Categorical is basically a descriptor. So in 13A, next class you would begin thinking about what we can learn from data. Sometimes we want to learn about populations that are very large, too large to study each individual, therefore we need a sample. Recall discussions in earlier lessons about sampling, populations, and inference. We will now extend these discussions into more specific about statistical studies and analysis. The tutorial for Lesson 13 Part A begins here. Recall, we have the population, we take a sample, and then based on what happens here we can infer back on what the bigger population may do. Okay, so government uses different kinds of data about their populations to make decisions on how to spend money and to construct budgets. Suppose a state government leader needed to know about how many children are born each year in order to plan for future school funding. What is the best way to learn about how many children are born each year? A. Survey a random collection of families across the states and use this data to estimate the number of children who are born. Survey every family in the state to learn how many children are born. It is impossible to learn, so there is no point in trying. Love that one. Okay, so this is look at everyone. This is look at a portion of random selection, of simple random sampling. So the question is, can we take a sample? Can we take a sample of the population and infer what's going to happen in the big picture? So I'm going to go with A. Basically, we're doing a poll of childbirth. Review the prompt. In statistics, the value assigned to the variable is an observation or characteristics that differ from one individual to the next. There may be more than one variable in a statistical study. Consider this statistical study. Suppose a doctor developed a new medicine to treat migraine headaches. To treat the effects of the drug, the doctor gathers volunteers who experience migraines and give a dose that varies from one volunteer to the next. During the study, when volunteers experience migraine, they take the prescribed dose of medicine and report whether the pain level is reduced. What are the variables in this study? Choose one answer. So the variable would be, let's see, dosage level and migraine headache. Dosage level, pain level. Pain level, migraine headache. Okay. So the study is basically migraines study migraine meds. And what are we going to do? Well, remember, X is explanatory, Y is a response. So for the migraines, we're doing two things with migraines. We'll have dosage of medicine, and we're going to measure what's this. Report whether the pain level is reduced. And pain level. So migraines to study. Our variables is pain level and dosage, which I guess what the question is. So that would be B. But thinking ahead, what makes sense? To have the explanatory being pain. Well, based on the pain, that's going to dictate the dose. Would it make more sense to have measure based on what the dose given, and with dosage measure the pain? That's probably going to be the next question. So we got to decide which one's the explanatory, which one's the response. And the explanatory, in many cases, we're doing these studies, more times than not, is the treatment. The treatment is we're going to dose you. We're going to dose you with a certain level of medication, and then we're going to measure the pain results, or the pain output, resulting pain. Either way, B. Yeah, that too. Okay, by conducting a statistical study with subsets of population, we learn about the population. Again, we take a subset sample, we infer the results onto the bigger population. Think about tasting soup before it is served to family or friends. What is the best way to taste the soup? Choose one answer. Just take a spoon from the top of the pot, stir the soup well before taking a spoonful, eat most of the soup in the pot, eat the whole pot of soup before you serve it to your families and friends, and tell you how good or bad it was. Well, sampling is definitely not these two guys. So sampling is, okay, we have the pot cooking. We just take from the top of the pot, where, hey, things, liquids can stratify, or just take a good statistical sample of the spoon of the soup by stirring it up, mixing everything up, randomizing the flavors, so there's not a variation in flavors. So B, stir it up, randomize it. It may not represent what's on the bottom because things may stratify. Yeah, just as you stir the soup up, care should be taken to have representation from across the population when selecting statistical samples. The word for this is randomize. Okay, several different types of variables in statistical studies. For example, variables can be quantitative or categorical. The value of a quantitative variable is a quantity or a numerical measure, which the following variable is quantitative. What can we measure? Can we measure eye colors in terms of a count? It's either blue eye, green eye, hazel eye, brown eye, some mix. So no. So this would be categorical. category. Gender. Again, can we count? Can we measure gender? It's basically, it's either yes or no, you're male, female, whatever. So this is also categorical. Weight. Can I measure weight? Yes, I can measure the weight. Varies anywhere from very little to very big. Yes. On a scale. Measurable. Job title. Can you measure a job title? A teacher, engineer, scientist, politician, also known as, well, politics, etc. So no. This is also categorical. It's a category. So the only one that is quantitative is weight. Numerical values or quantities. The value of a categorical variable is a category. Makes sense. Group or verbal description. This type of variable is also sometimes called qualitative, which the following variable is categorical. Hair color. That's not a number, that's a word. Arbor, blonde, brunette, neon green. Height, I can measure height. Quantitative. Age, I can definitely give a number for age. 59, 21. 12 and a half. Income. That's measurable. You made $20,000 a year. You made $55,221, of which $45,000 was taxable. I don't know. But again, that can be described with a number. So it would appear that only hair color here is categorical. We make categories people by their hair color. I'll refrain from any jokes. Okay, suggestion. Maybe wish to devote a section of your notebook to statistical vocabulary. Also consider going back to lesson 3 to refresh on some statistical concepts studied earlier. So how confident are you that you can describe a way to use sample data to describe population? Well, we haven't done any of that yet, so I want to say I'm not sure how confident. We haven't quite done that yet. How confident are you to determine the variable is in a statistical study? In a study, what is the variable? Somewhat confident. And be choose between quantitative or categorical. Very confident. Okay. So in this lesson, we did some describing on how to use data. Determine what variables are in this statistical study, and ID both the quantitative and categorical data. What could be quantitative, what could be categorical. So with that completes the interactive tutorial. So go back and do it yourself again, and I'll see you shortly for questions 1 through 5.